Hello students, thank you for watching and welcome to part 1 lecture video of Statistics for Management 2 on chapter 3. Chapter 3 is about hypothesis testing. Let's begin the chapter by defining hypotheses. Hypotheses are tentative explanations of a principle or theory operating in nature. A common statistical mechanism for decision making is the hypothesis test. Before we make a decision, it is better if we try to test a theory, if we try to test a principle in nature. Therefore, hypothesis testing is a most important statistical tool for decision-making purpose. Business researchers are also able to structure problems in such a way that they can use statistical evidence to test various theories, principles about business phenomena. Let's deal with types of hypotheses. There are two major types of hypotheses, and these are research hypothesis and statistical hypothesis. Let's deal with research hypothesis. A research hypothesis is a statement of what the researcher believes will be the outcome of an experiment or a study. Therefore, a researcher expects what will be the outcome, the finding of a study, and that this expected outcome of the study or experiment is considered to be a research hypothesis. Ideas, theories, notions based on experience or previous work established before an experiment or a study. Therefore, these are the basis for the expectation of the outcome of an experiment or a study. But to formally test research hypotheses, it is best to state them as statistical hypotheses. Statistical hypotheses are hypotheses consists of two major parts: null hypothesis and alternative hypothesis. These two major parts of hypothesis are constructed to contain all possible outcomes of the experiment or study. When null hypothesis states the null condition exists, that is, there is nothing new happening, the old theory is still true, the old standard is correct, and the system is in control. However, alternative hypothesis states that new theory is true. It also states there are new standards, there are new principles, there are new theories, and the system is out of control or something is happening. This is the way by which null hypothesis and alternative hypothesis are constructed to contain all possible outcomes of a study or research. It's common to represent null hypothesis as HO and alternative hypothesis as HA. Statistical hypotheses are written so that they will produce either one-tailed or two-tailed test. Let us deal with these two types of tests. In two-tailed tests, we always use equal and not equal sign in the statistical hypothesis, and the two-tailed tests are directionless, that is, the alternative hypothesis allows for either the greater than or less than possibility. On the other hand, one-tailed tests are always directional, and the alternative hypothesis in this test uses either greater than or less than sign. Let us proceed to steps in hypothesis testing process. In the process of conducting business research or experiments or study, we work through four major tasks in hypothesis testing. Task number 1 is establishing the hypothesis. Then we start to conduct the test, which is task number 2. Task number 3 is taking statistical action. Then finally, determining the business implications is task number 4. The process of testing hypothesis by working through these 4 major tasks is referred to as HTAB system, which stands for hypothesize, test, action, and business. It's common that statisticians and researchers present the hypothesis testing process in terms of an 8-step approach. Therefore, these 4 major tasks involved in the process of hypothesis testing are presented in terms of 8 steps approach. Let us deal with this 8 steps approach. The first step is establishing both non and alternative hypotheses. Step number 2 is determining the appropriate statistical test. Then we set the value of alpha, which is type 1 error rate, in step number 3. Step number 4 is establishing the decision rule. Then we gather sample data, and at step number 6 the data will be analyzed, and the next step is reaching a statistical conclusion, and the final step in the 8-step approach of hypothesis testing is making a business decision. When we link these 8 steps to the 4 major tasks involved in hypothesis testing, task number 1, which is hypothesizing, includes step number 1, and the task number 2 of HTAB system embraces testing, includes step number 2 up to step number 6. Task number 3 of hypothesis testing involves step number 7, and the final task of the HTAB system of hypothesis testing involves step number 8, which is the final step. Therefore, generally, in order to test hypothesis, we need to work through 4 major tasks in general and 8 steps in particular. Let's deal with other concepts related to hypothesis testing. When we use the critical values that we establish at step number 4, the possible statistical outcomes of a study can be divided into 2 major groups or regions. The first one is those that cause the rejection of the null hypothesis, which is known as rejection region, and the second one is those that do not cause the rejection of the null hypothesis, which is known as non-rejection region. The other concept that we need to know when we study hypothesis testing is type 1 and type 2 errors. There are 2 types of errors that we make or that we commit in the process of hypothesis testing. These are type 1 error and type 2 error. Type 1 error is committed by a researcher or a statistician when he or she rejects a true null hypothesis, and the probability of committing this error is known as alpha, or it is also named as level of significance. Alpha is equals with the area under the curve that is in the rejection region beyond the critical value or values. The value of alpha is commonly set before the experiment or the study is started, and it is common to determine the value of alpha at 5%, 1%, 10%, or 0.01%. On the other hand, type 2 error is committed when a researcher fails to reject a false null hypothesis. Therefore, the error of committing a mistake or the error of failing to reject a false null hypothesis is considered to be type 2 error. And the probability of committing this error is known as beta. Unlike alpha, beta is not usually stated at the beginning of the hypothesis testing process. And when we deduct beta from 1, we obtain power, which is the probability of a hypothesis test rejecting the null hypothesis when the null hypothesis is false. Therefore, in the process of testing hypothesis, business researchers commit either type 1 error or type 2 error, which are represented by alpha and beta. Let's deal with how business researchers test hypotheses about population mean. When the population standard deviation is known, in order to test hypothesis about population mean, we use a normal distribution or Z statistics. And testing hypothesis of a population mean is one of the most hypothesis tests in, business phenomena. And when the population standard deviation is known, and when the sample size is large, i.e. when n is greater than or equal to 30, and for a small sample when n is less than 30, that if x is known to be normally distributed in the population, we apply this Z formula. Z is equals to x bar minus mu all over standard deviation or sigma divided by square root of n, where Z is observed value or Z value, x bar is sample mean, mu is population mean, sigma is population standard deviation, and n is sample size. Let us deal with one example about hypothesis testing of population mean. Suppose that a survey of certified public accountants across USA found that the average net income for sole proprietor CPA is $74,914. And because of this survey is now more than 10 years old, an accounting researcher wants us to test this figure by taking a random sample of 112 sole proprietor accountants in the United States to determine whether the net income figure is changed. If the researcher could use the 8th step of hypothesis testing to do this testing, and if he or she assumed the population standard deviation of net incomes for sole proprietor CPA is $14,513, let us deal with how she or he will test hypothesis about the average net income of CPAs by working through HTAB system. In HTAB system, we find about 8 steps, so that let's begin by the first task number 1, which is hypothesize. At task number 1, we establish null hypothesis and alternative hypothesis. Therefore, step number 1 will be establishing null hypothesis and alternative hypothesis. Because of the researcher is testing to determine whether the figure has changed, the alternative hypothesis is that the mean net income is not $74,914. On the other hand, the null hypothesis is that the mean still equals $74,914. And then formula we can state as H naught or HO is mu is equals to for $74,914, and H sub A or HA is mu is not equal to $74,914. Then the next task or task number 2 is testing. And under task number 2, step number 2 or the first step is determining the appropriate statistical test and sampling distribution. Because of the population standard deviation in our case is known, which is 14,530, and because of we are going to use the sample mean as the statistic, Z statistic formula is appropriate test statistic. Therefore, we apply the test formula, which is Z is equals to x bar minus mu all over sigma divided by square root of n. Step number 3 is specifying alpha or type 1 error rates, which is in our case 0.05. The next step is stating the decision rule. And because of the test is two-tailed and the alpha is 0.05 or 5%, there is alpha over 2 or 0.025, which means 0.05 divided by 2 is 0.025. Therefore, there is 0.025 area in each of the tails of the distribution. Hence, the rejection region is in the two ends of the distribution with 2.5% of the area in each. This is, to say, the rejection region and the, non-rejection region. When we deduct 0.025 from the probability of, each tail, which is 0.5 or 50%, we obtain 0.475. Therefore, there is a 0.4750 area between the mean and each of the critical values that separates the tails of the distribution or the rejection region from the non-rejection region. When we use 0.4750 area and when we look at the distribution, the critical Z value can be obtained, which is 1.96. Let us look at or find this value, and we find 0.475, 0 points here 475. Therefore, then it will be about 1.1. Here, this is the value of the probability, which is 0.475. Therefore, the Z value here is 1.9. We go up, and here we find 0.06. Therefore, this probability is at Z score of 1.96. This is how we can find the probability from the distribution. And we can also display the problem with the rejection regions and the critical value of Z value. Therefore, the decision rule is that if the data gathered from a sample results a Z value greater than 1.96 or less than negative 1.96, the test statistic is in one of the rejection regions, and the decision is to reject the null hypothesis. However, if the observed or calculated Z value is between negative 1.96 and positive 1.96, the decision is to not reject the null hypothesis because of the observed Z value is in the null rejection region. This is how we can display non-rejection region and the rejection region when alpha is 0.05 and alpha over 2 is 0.025. And therefore, I mean to say Z value at 0.4750 is 1.96, so that since this test is two-tailed test, we state here minus 196 and positive 196 in this diagram. Therefore, if we obtain a value which is which is a value or Z calculated or observed value, or simply Z value between negative 1.96 and positive 196, we are going to reject the hypothesis. But if the calculated or observed Z value is greater than positive, or I mean to say negative 1.96, we are going to reject. Therefore, this is how we can show the non-rejection and rejection region. Step number 5 is gathering data. Suppose that 112 CPAs who respond produce a sample mean of $78,695. Therefore, step number 5 is gathering sample data and calculating a sample mean. Step number 6 will be calculating the test statistic. Therefore, in order to here calculate Z value or observed value of Z, we first need to calculate sigma or population standard deviation. In our case, if we assume that from the gathered sample data, if sigma or population standard deviation is calculated and it is determined to be 14,513, therefore Z value will be calculated as Z is equal to x bar minus mu all over sigma divided by square root of n. Let us substitute these figures in the formula. Therefore, Z is equals to x bar is 78,695. We take here minus mu or population mean is 74,914. Then we take here all over sigma or population standard deviation is 14,513. So we take here divided by square root of n, in our case is 112. Finally, Z value will be 2.75. Therefore, because of this test statistic, which means observed Z value is 2.75, which is greater than the critical value of Z in the upper tail of the distribution, which is positive 1.96, the statistical conclusion reached at stage 7 of the hypothesis testing process is to reject the null hypothesis. The calculated test statistics is usually known as observed value. Therefore, the observed value of Z for this problem is 2.75 here. And the critical value of Z or table value of Z for this problem is 1.96. The final step is making a business decision. Therefore, from our result, statistically, the researcher has enough evidence to reject the figure of $74,914 as the true national average net income for sole proprietor CPAs. Also, researcher conducted a two-tailed test. The evidence gathered indicates that the national average may have increased. The sample mean of $78,695 is 3,781, which is higher than the national mean being tested. The researcher can also conclude that the national average is more than before, but because of 78,695 is only the sample mean, it offers no guarantee that the national average of the CPAs is $3,791 or more. This is how we can present the business implication of our hypothesis testing results. This is the first part, lecture video of hypothesis testing. Thank you for watching, and try to study well and try to solve exercises relevant to hypothesis testing of population mean when sigma or population standard deviation is known. Thank you for your time and have a nice study until we meet each other with part 2 lecture video of this chapter. Thank you.